the best case scenario. Okay. More in design patterns. So reusability is an important aspect. So let's go in detail. Why do we need to be masters? I mean, the masters of software development, okay? And why design pattern will help you to do that. If I were you, I'll spend the 3 weeks. If I were you, I'll do a lot more on these design patterns so you're ready. Because these are solutions. They've been already shared as expert solutions. So let's try to do the imitation game. Have you ever anyone played chess before? One? Oh, well done. Okay, so you know the game. If I want to be a chess master, okay, what I'm gonna do? First, I have to learn the rules, the physical requirements, the names of the pieces, the legal movement, the chessboard geometry, the orientation. Then, I'll learn the principles, the relative value, the strategic value, the central square, the power of trade, etc. These are the basics now. But then if I want to be a master in chess, then I'll need to study other masters' games. Okay. Therefore, what does that mean? That means I'll need to look at all of these previous masters and how they defeated their enemy in 3 steps, and 4 steps, and 5 steps, 6 steps. And I memorize them. Yes, I memorize them. Yes, I practice them once and twice and 3 times. Because they could be part of your strategy to defeat your enemy, okay? Therefore, if you learn them and you are just a novice, and they are in the back of your mind while you are playing with your counterpart, are you behaving like an expert? Yes or no? Does that make sense? Are you behaving like an expert, a master? The person in front of you, if he is a master, and he is sitting in front of you, and he sees your movements based on 1, 2, 3, 4. Obviously, you're going to go with the fastest approach then. He picked it up, then you go second approach. He picked it up, you go third approach. He picked it up, you go 5th, 6th, 7th, 10th, etc. Then the person next to you, he will say, what I'm doing, he's a master, okay? But what the truth is not the truth that this person just memorized all the previous tricks and he's ready to go ahead. Okay. Okay. What about software development? In software development, if you want to do that, let's go the game. The game is learn the rules, algorithms, data structures, languages, you know it all. Principles, structured programming, modular, object-oriented, generic, C++, Java, C#, Visual Basic, SQL, some web development, JSB, Hibernate, Spring. Okay. Then, to be a master, and in which you go into and jump into an institution within a software development team, and they will say, we're going to develop this piece of software that, for example, going to produce a simple web application. If you start talking about, oh, I've got a series of JSP files, they will stop you. If you say, oh, I'm going to use Spring MVC or an MVC controller, okay, that is a good start. Where they are, the best solutions. So, from talking to the industry, they don't really like a lot now you producing lots of JSP as a product for their web application, because handling the traffic is nightmare. I mean, the MVC controller, from a security point of view, is better than just managing the traffic to all of these different pages. It goes through the controller. All the traffic goes through the controller. So the controller is handling the traffic, etc. That's from one point of view which you can defend it. Straightforward. Okay. So what you've done there is you've reused the design pattern. Then you mention, let's use Hibernate. Okay, what is Hibernate? Your architect knows what's Hibernate, and he wants to push the rest of the developers to use Hibernate. Therefore, you are acting there like an expert. And this is what we want to make sure you do. So I'll return to Nick's comment. That will help you with writing your report, because I assume you're writing a report on the assignment you've developed. He said, one idea, can you remind them you can write about design pattern you've used? So you can show in your work including your thesis in the previous years, when you write the implementation chapter of your thesis, your report for the project, that chapter tends to be so thin because the students don't know exactly what to write. It's a software they've implemented. They've got few screenshots. You've got introduction and conclusion. This is what I've done. Usually others, they bought the key challenges and how they've resolved them. And some, they bought design patterns we used. Expert way of, because at the end of the day, you'll need to defend that. You need to say, oh, I want first class. How could I show that this is a first class? If you show that you've got unique elements inside, because the main, you've got two examiners, the second examiner, is it really challenging problem what he's done? Does it work first class? Did he really put lots of efforts? Was it so unique? Was it innovative? Is it a great idea? Was there lots of efforts put in? Okay. So you can show that within the implementation chapter. Okay. So design, software design pattern. So at the end, what we've agreed now, it's a template solution for a reoccurring design problem. It is a reusable design knowledge. It should be reusable. It is not as low as linked list and arrays and binary trees. It's not at that level. And it's not reusing the whole application. It's a bit in the middle. Okay, I can't look at this moment where they are. I'll show you an example in a minute. It will be at classes level. It will be static at some times and dynamic at others. I'll clarify these in a minute. Okay? So the best thing...
Sorry to interrupt you. So I just want to clarify this.
I will.
So design patterns are basically any external libraries and external code that we can reuse in our project.
No. Because not any external libraries we could use.
Oh, well, the one that fits the project, obviously.
No. That is rendered as an expert solution to that specific problem. Yes.
But
Not just any. Any is confusing the answer.
Yeah, obviously, but it's still the external pieces of libraries and code that we can use.
Sometimes it's external, sometimes you take it internal. And in the example, I'm going to show in a minute, it's kind of external at the same time you tend to use it a lot as well inside. Okay? And there is different categories of design patterns. There is behavioral, there is structural, and there is creational. I mean, it depends on what kind of things these patterns you are reusing. It's not just one simple style. There is many different to deal with the project, such as structural. There is a design pattern called the adapter. You plug something into it in order to plug it somewhere else. Behavioral deals with how the system is behaving. Creational is to deal with the creations of things, like creation of new instances in real time, etc. We will come to these. It will be fun. I can see you are interacting well now. Okay, so therefore I'll go to the first example. Okay. Okay, is that okay?
Yeah, that's fine.
Is it clear for the rest? Good. Again, I'm going to move a bit faster on this slide. It's just a slide emphasizing what is a design pattern. It's a problem, a reoccurring problem, and its solution in context. Okay. Because I want to jump to this. That is our first simplest example. Imagine I have a file on my system, and I have all of you wants to keep track of that file. Any change happens to that file should inform you all of that change. Okay. Another example to show you that it's a reoccurring thing. Imagine we've got an auction system, and there is an auction item. This is the item I'm selling. Okay. Might be this one, etc. And any change happens to that auction item, somebody put a bid on it, somebody increased the price, somebody changed the description, all of those viewers of that item should be informed instantly. And the same story, this is a reoccurring. In Drop the Box, there is a shared file. Any change with that file, all of those should be informed. Okay. That is called the observer design pattern. Obviously, the subject is something called the observable. The observable, it's a well-known design pattern. The observable is where the eye is on, where those people want to observe it. You are the observers, and this is the observable. Okay? Observers, observable. We can call it model view. Publish, subscribe. People publish subscribing to a news group. Any change sent to everyone. Okay. So it is a generic problem. We need a solution to it. We have a number of challenges to this. Challenge number 1, how do we notify those observers? Challenge number 2, how do we save them? The biggest maybe 3 is they are different. I mean different. Here is an easy example. All of you will be of a student class. But what about, I've got media stuff, marketing stuff, and accountants, and the NCC opposite to us. And all of them, they want to watch this item, and they've got different instances for their classes. So those watchers or observers are of different types. Because one of you might think this, a bad and ugly solution. Okay? This is the observable. I called it subject observable, extend subject. And I've solved it having a vector. If you forgot what a vector means,